Welcome to this unit where I'm going to explain where or in which context, for example, the use of systems of linear equations and the solution thereof might become handy. One idea are examples like this, which you might know from social media or from other internet pages, where you have a set of symbols, small images, whatever, like here with shoes, which are combined. Here I just added the plus, minus, or equal to part, but it could also be you just see, like in the first row, two of these slippers, one women's shoe, and you see a number 3. Then you see two women's shoes, one man's shoe, and you see a number of 2. Two slippers. Well, this is a bit more problematic because here I have a minus. But still, it could be something like this. This should give 1. And then, usually in the 4th or 5th row, you get a question like, what is this? So like 3 slippers, a set of women's shoes minus a set of men's shoes. What number is associated to this part? Well, a riddle like this could easily be answered by solving a linear system of equations, because the part here can be represented by this linear system of equation. Because if we consider x to be the amount of slippers, y being the number of lady shoes, z being the number of men's shoes, then here we have basically 2 slippers, 1 women's shoe. This should be equal to 3. Here we have 2 women's shoes plus 1 man's shoe, giving us 2. And finally we have 2 slippers minus 1 man's shoes, so minus 1 here. This should give 1. So what we can do in the first step, we have this system of equation. We can solve this for x, y, and z. Then we have x, y, and z, so we have the number associated with slippers, with women's, and with men's shoes. Then we can use this information to actually calculate 3 slippers plus, or 3x, plus 2 women's shoes, so plus 2y, minus set of men's shoes, so 2 men's shoes, or 2z. That's basically this part here. So that's what we want to know. So that's where we can use those systems of equations. And if we can use them with these graphical riddles, we can also use them in some kind of text riddles. That's something like this. Heiner owns a pet shop for birds and guinea pigs. Questioned about the number of animals he owns, he answers, including my dog and the cat. All animals taken together have 89 heads and 206 legs. Question then might be, how many birds and how many guinea pigs does Heiner own? Well, first off, this is only about birds and guinea pigs, so we have to exclude the cat and the dog. Well, here we have 89 heads. The dog usually has 1 head, the cat has 1 head, so we have to subtract 2 heads, giving us 87 heads. The cat and the dog each have 4 legs, so we have to subtract 8 legs here as well, giving us 198 legs. So we know all birds and all guinea pigs taken together will have 87 heads. So if x is the number of birds, y is the number of guinea pigs, it's like 1 head per bird, 1 head per guinea pig, added all together give 87 heads. So the second equation actually is for heads. So the first one is for legs. Here we have each bird has 2 legs, plus each guinea pig has 4 legs. So 2 times the number of birds plus 4 times the number of guinea pigs should give us 198 legs. then we can solve this equation for x and y, giving us the number of birds and the number of guinea pigs. And that's basically what this question was all about. So we see we can answer a lot of, well, text problems, a lot of graphical or text riddles by transferring them into a mathematical formulation and then solving the corresponding mathematical problem. That's what linear systems of equations are well suited for.